Okay, this is warm-up 11.5. We're going to be finding the area of this regular octagon, and this method will work for any regular polygon. So I've got it broken down into sub-questions, but really what we're working towards is finding the area of the whole figure. Okay, so first we're going to find the measure of a central angle. So if I'm thinking about this as a pizza, here's one slice of my pizza, and so this would be one of my central angles, okay? And if I draw in all of the slices of pizza, if I'm going to the corners, each one of these is a radius, by the way, that goes from the center to the vertices. Okay, so there's 8 total slices of pizza there, and this is one of 8 slices, and altogether I've got 360 degrees of pizza there. So that means one of my central angles, I can just take 360 degrees and divide it by 8, which is going to give me exactly 45 degrees. Okay, so that's the measure of a central angle then, 45 degrees. Okay, the apothem is a segment that if you draw, it's the distance from the center to any of the sides. So it's the shortest possible distance. So if I'm going straight down at a right angle to that bottom side, this would be the apothem. Okay, that didn't show up very well, but it's this green segment here is going to be the apothem. I know some people say apothem, I say apothem. Okay, so that's what I'm going to find next. Okay, and the way I'm going to do that is by using this triangle here. Okay, so it's a right triangle because it's got to be the shortest distance to that side. So let me draw that out here, just to make it a little bigger. It's like a half slice of pizza. Okay, so this is going to be the apothem. And what I can do is use the radius I can see is 14, so this radius would also be 14. Okay, so I can put that into my picture. I can use SOHCAHTOA. So I'm going to find this angle up here, and the way I'm going to do that, it's the angle for a half slice. So it should be half of 45 degrees because I've got a total of 45 degrees here. These two triangles are congruent to each other, by the way. So I'm not going to go through with proving that, but we could do that. Which means those two angles are congruent. So each one of them is half of 45. So this angle then is going to be 45 divided by 2, which gives me 22.5 degrees. Okay? And now I've got a situation where I can find the apothem by using SOHCAHTOA. So I'm thinking it's going to be sine, cosine, or tangent. I need the one that is going to work with this triangle. I want to put myself at the acute angle over here, and then I'm thinking, okay, this is the opposite side that's not marked. So what I do have is the adjacent and the hypotenuse. So in this particular instance, I'd want to use cosine because that's the only part of SOHCAHTOA that uses adjacent and hypotenuse. So I'm going to say the cosine of 22.5 degrees, that's where I am, is going to equal A over 14. The apothem over 14. Okay? And then I'm going to want to solve this. I'm going to want to isolate the A, so I'll multiply both sides by 14. Because then those will cancel. And now I've got something I need to put into my calculator. Okay, so here is a calculator. You need a scientific calculator for this, so I'm going to type in 14 cosine of 22.5 degrees. You'd want to be in degree mode. If you're in radian mode, you'll get a different answer. So this is about 12.93. Okay. So now that we've got that, let's find a side length. All right, and we can find a side length using the same triangle. So let's find x here. X is going to give me, if I'm thinking about this as pizza, it's the crust of a half slice. So I would just double that because this would also be x to get the side of one of the sides of the octagon. Okay, so looking back to this triangle. This is the opposite, so now I could use, since I know what the apothem is, I could use that, but I'm going to use the hypotenuse since that was given. So I'm going to use opposite and hypotenuse. That means I'm going to use sine. So sine from the 22.5 degree angle, I'm thinking opposite over hypotenuse, that would be x over 14. And again, I'm going to multiply both sides by 14 to solve for x here. Okay, and I need a calculator again. So let's see, 14 times sine of 22.5 degrees gives me about 5.36. Okay, and then my side, remember, my side is going to be twice that big, right? Because that was just this piece. So my side is going to equal about 2 times 5.36, and that's going to give me about 10.72. I'm going to the nearest hundredth on all of these, but if you round it differently, that's okay. Okay, so there's my side length. All right, so going back to the diagram, now I've got 10.72 for an entire side length. Now, since this is a regular octagon, that means all of the sides and angles are congruent. So all of the sides would be 10.72. You don't necessarily need to write them all in, but I'm going to use all of these to find the perimeter. So I've got 8 sides, 8 10.72s to add up to find the perimeter. So the perimeter, rather than adding, I'm going to do 8 times 10.72. And I'm saying about because the 10.72 is rounded, right? So this is about 85.72 then. Okay. Now that we've done all of that work, we can find the area. So there's 2 different ways to find the area. One, you could find we could find the area of each slice of pizza here, right? I could find this because I know what the apothem is and I know what the base is. So you could use 1/2 base times height to find the area of the slice and then just multiply by 8 because all the slices are the same. Or you can use the area formula for all regular polygons, and that's 1/2 apothem times perimeter. Since I already have the apothem and the perimeter, I'm going to do this. So my area is going to be, let's see, the apothem going back here was about 12.93, and then the perimeter was about 85.72. Okay, and then I multiply that all together, and that's going to come out to about 554.19. And since this is area, I want to say that the units are squared, even though I don't know what the units are. They're square units. Okay, and hey, I found the area of that regular octagon, only knowing one measurement, the radius. Okay, that's it for this warm-up, and I'll see you next time.